Hello and welcome to another one of D's A to D videos. Today we're going to be looking at Hess's law, discussing enthalpies of reactions and multi-step reactions that need manipulation of their enthalpies in order to get the overall enthalpy of the reaction. So, what do I need to do? What do I need to discuss? What do I need to know in order to be proficient in discussing enthalpy? What is enthalpy? Well, when we start talking about heat at constant volume, then heat is referred to as the enthalpy. If you remember, the internal energy of any system is the heat plus the work. And work can be defined in one of two ways. In physics, you probably learned that work was force applied over a distance. Well, here we're going to look at it as pressure over the change in volume, because what we're doing is usually in a beaker and doesn't really travel, so it wouldn't make sense to use that definition of work. There's no distance traveled. But the volume usually does change, and as a result exerts some pressure. So if you have it in some sort of enclosed container that allows the volume to change, then you can calculate work, knowing the pressure. But what happens when the volume becomes constant? What do we do then? Well, at that point, we have, this is just the work formula plugged in, right? And at that point, we have constant volume, no change in volume. If it's constant volume, what we're saying here is that V1 will equal V2, or VF will equal V initial at constant volume. So when you do the change in volume, change is always, delta is always final minus initial. So if we do VF minus VI, what will that equal? That equals 0. If that equals 0, well, what happens to that whole work term? Work goes to 0. So all we're left with is heat. And at constant volume, we refer to this heat as enthalpy. Now, whether we're discussing enthalpy or enthalpy at standard state, which means that we have 25 degrees Celsius, 298 degrees Kelvin, 1 bar of atmospheric pressure, and 1 molar concentrations of everybody, then we use this little degree thing attached to our enthalpy symbol to indicate we're at standard enthalpy. So, if I wanted the change of either standard enthalpy or regular enthalpy, I would just do the products minus the reactants. And we could look at it for one-step reactions this way. Look at the enthalpy of each product and the enthalpy of each reactant, sum them up, and then do the difference. Now, what happens if we have multi-step reactions? Well, that's when Hess's law comes into play. Hess's law now is going to have some rules that allows you to manipulate a multi-step reaction to get an overall chemical equation that you desire. So each step is necessary to create the final result that you want. And each step has its own delta H. So when you manipulate delta H, what are you going to do to these? When you manipulate these equations, what are you going to do to the delta H's? Well, here are the rules. If you reverse it, well, when you reverse an equation, your products now become reactants, and your reactants are now products. So delta H is products minus reactants, and if they're vice versa, all you did was take the negative of it. So here's an example equation, A plus B yields C. Now we're looking at C yields A plus B. So you take the negative of your original enthalpy. what if you multiply or divide by a number? Well, if you multiply by some number, then you take your original enthalpy and multiply that original enthalpy times that number you multiplied your equation by. In this case, number 2. If you divide, same principle, take your original enthalpy and divide by that same number. You can see these rules aren't too complex. Make sure that you add the equations, and when you cancel only what is the same. So on the left and the right, if you have water, you can cancel water. They have to have the same number of coefficients, though. Enthalpy is a state function, so therefore the water solid has to cancel only with water solid. You can't cancel water solid with water liquid. Okay? And enthalpy is always also extensive. Depending on how much amount we have present of your sample, then it'll dictate how much heat is going to be given off. So extensive properties are dependent on amount present. So check out the example video. This is just a quick recap on enthalpy rules and Hess's law. Practice, practice, practice. Thank you and have a nice day.